Hey everyone! This week we switch gears and we start talking about matrices. If you've never talked about a matrix before, it's just a way to organize numbers, data really. We call it an array, and numbers are organized by rows and by columns. Rows go horizontally, columns go vertically. So the matrix that's given here on your notes has 2 rows and 3 columns. The term element is what we call each number within a matrix. So if I ask you what element is in the second row and first column, here's the second row, here's the first column, the element that's listed there is 1. We usually call the number of rows and number of columns the dimensions of the matrix. So if I ask you how big it was, you would say that this is a 2 by 3. We always list rows first. Matrix, and we usually name matrices with a capital letter, single capital letter. So for example, if we took this matrix and we represented it just with any numbers, this is element A11, element A12, element A13. Again, always remembering that the row comes first and then the column. Okay, so just some more examples with a new matrix. This is also a 2 by 3 matrix in matrix B. Okay, so what can we do with them? Well, we can do a lot of mathematical operations, the first one being adding. Adding matrices is very simple. We just add the numbers that are in matching positions, and our resulting matrix is the sum of each of the numbers in the respective positions. So we would add row 1, column 1 with row 1, column 1 in the second matrix, and our answer goes in row 1, column 1 of our answer matrix. With that being said, in order to add 2 matrices, they need to have exactly the same dimensions. Same thing with subtracting, which is really just adding a negative. We can only subtract matrices that have exactly the same dimensions, and then we just subtract numbers that are in matching positions. We can also multiply with a matrix. The first way is multiplying a matrix by a constant. And this is really just like distributive property. We essentially distribute whatever the number is outside, which we call a scalar, by everything inside. And so the resulting matrix is the same size or has the same dimensions as the matrix that we're multiplying. We call this scalar multiplication. But we can also multiply 2 different matrices, and this is where things get a little bit different. To multiply a matrix by another matrix, we do what's called the dot product, where we multiply all the numbers in one row with all the numbers in one column. And then we add those sums together. So it's a little bit more complicated. So the resulting matrix will not always be the same dimension, and that doesn't mean that we are limited in multiplying only matrices that have exactly the same dimensions the way we are with adding and subtracting. And in fact, because of this dot product method, sometimes matrices with the same dimensions can't even be multiplied. So let's talk about why that is for a second. So I'm going to skip down here for a second. Okay, so the number of columns of the first matrix must equal the number of rows of the second matrix and vice versa. The reason for that is because of the way that we do this dot product where we multiply rows and columns, we need to have always numbers that correspond. And so we need to have matching elements within a row and matching elements within a column of the second matrix. So in general, if you write the dimensions of your 2 matrices, the number of columns in the first has to match the number of rows in the second in order for them to be multiplied together. And then additionally, the number of rows in the first and the number of columns in the second become your resulting or your product matrix. So these 2 inside numbers have to match, and these 2 outside numbers give you the dimensions of your product. So if we come up here, this is a 2 by 3 matrix, and this is a 3 by 2 matrix. So the 3 and the 3 match, the two middle numbers match, so they can be multiplied, and the 2 and the 2 on the outside becomes our answer matrix, or product matrix. And again, to do this, we're going to multiply 1 by 7, 2 by 9, and 3 by 11, sum those numbers, and then the answer goes right here. So it's complicated, but the way that I think about it is actually create my product matrix first, and I say, okay, this is in position 1, 1, or row 1, column 1, and that tells me I'm going to multiply row 1 of my first matrix by column 1 of my second matrix. To get this number here, which is in row 1, column 2, I'm going to multiply row 1 of my first matrix by column 2 of my second matrix. So in this case, I'm going to multiply 1 times 8, 2 times 10, and 3 times 12. That's what they're showing here. And then I'm going to sum them all together, and that gives me 64. So you do that for each of the elements in your product matrix. So you can see that that's what they've done. In the second row, first column, they got 139. And in the second row, second column, they got 154. So there's a lot of practice for this. And of course, if you have questions, you can come ask me. Okay, so this we kind of talked about already. Just keep that in mind. And then finally, division. So there is no such thing as dividing matrices. So what we're going to do if we ever need to divide by a matrix, what we're going to do is we're going to multiply by its inverse matrix instead. And we're going to talk about that more next week. So take a look at the practice and let me know if you need extra help.